Basically, in the market now we are looking on these buzzwords like DevOps, artificial intelligence, machine learning kind of. Basically, if you go with the DevOps, first, I want to introduce myself. I have 12 plus years of experience in automation, and I'm almost from past 5 years I'm working in DevOps team as well. So my core skills are using the DevOps cloud tools mainly, and I'm certified as a CCNA and AWS solution architect. Just a week back I was certified for Kubernetes as well. So coming to the DevOps, what we are going to cover in this DevOps session is like be around 30 to 40 days of session, and we'll be using lot many tools which will give us the confidence like why this DevOps is used and what is the main motto of using these many tools. We have to know about each and every variant, what is in the market and how it is developed and how it is useful for us in our daily life. So if you know those things, then we can be easily, first we need to know the basics of each and every tool, why it is used and how it is used. And then only we'll be like good in DevOps. Otherwise, if you are, because in the evolving world in DevOps, there will be lot many tools which are coming up to solve different problems in our daily life. So coming to the DevOps introduction, as everyone knows, like DevOps is not a job role kind of. There was a problem in industry. To solve that problem, people have worked on different strategies. So they came into one strategy which is solving the problem. Problem is like between the development and operation. DevOps means dev and operation. Development and operation. There was a problem between development and operation because as an end user, we expect a lot that our software should work in good manner and a stable manner. Otherwise, whatever the software we take, it will not be useful for us. Suppose why DevOps came in this evolving world, I can give one example. If you take in my experience, I have seen like I was in a telecom world where I used to test the telecom protocol and I used to automate this telecom protocol. Even if you see in 2008, 2010 time, Android has evolved like anything. Android phones have evolved like anything. And if you see the Nokia was with symbiosis. There was a quick change in the mobile world where Nokia was not able to cope up with. There was always a fight. Development used to give like this is the software which is going to rule the world, and operations used to say this is not the software and it is not the proper. It is not stable in the market. We have to adapt to Android. But Nokia didn't do that. Nokia went off and even Samsung has taken the whole market. To solve this type of problems between the development and operations, because development used to do some quick changes which can impact the stability of the product. So development and operations have to work together to solve this problem. So in my PPT also I have mentioned like talking in layman terms, we can see that DevOps is a term that is used to align the development and IT operation. The DevOps teams work along with the development, ensuring improved communication and teamwork. So if you see, and people used to say like what are the job roles in the DevOps, what jobs we used to get. Some will say like we'll be like site reliability engineer, some will say like we'll be like support guys. So these are all like confusing people why we have not come into the DevOps world. It is not like that. A DevOps engineer is not a site reliability engineer, or is not a pure developer, or is not a pure operational guy. It is like a whole job who understands the development work and who understands the operation work and does both in communicating with developers as well operation. Like it is like he is a channel. He will be a channel. It's a philosophy kind of thing like that. He should have the development knowledge a little bit and operation knowledge a little bit so that he can use the tools which can helpful for the developer and it can helpful for the operation. We cannot say like it's purely developer job. We cannot say like purely operation job, because in the evolving world we are doing the automation, purely automation of all the things. Like if you see versioning control, we used to do the versioning control using Tortoise in the previous years, and now we have a distributed server architecture which has it, and we used to do some automation using Jenkins. We builds using Maven and tool, and we run the tests and we pass the build and we deploy the build in the production. It has lot many tools. Even if you come to the cloud, in cloud, even if you use Amazon, Google Cloud, Azure, you are automating your infrastructure using Terraform. That is one of the tools which is like automatically launches your servers in the cloud and which maintains the state. So in this way, we need to cope up with all the tools which are present in the present market and which comes under the DevOps job role. As I told, there is a problem between the developers and the operation. So developer focus on quick changes and operation focus on the stability. So obviously, end user need product which has good features and a stable product. To solve this problem, always as stated, the problem is like we need to adapt to the quick changes and our product should be on a stable. So to solve this problem, we have to be collaborative, communicative and integrated with the developers and operations, and we need to automate all the tools, all the operations which are reduce the manual work. Main intention is in the software world is like we need to reduce the manpower. We can say like it is eating the job market of all manual guys. To come into the DevOps, we need to be ready, we need to be adaptive to the new technologies. If we are not able to understand, we should dig into that and we should learn it properly. So this is the brief introduction about the DevOps, why the DevOps is evolved. So this is our course curriculum, what and all we are going to learn. Just now we saw the DevOps introduction. We'll be first learning the virtualization. In virtualization, I'll be explaining how exactly the virtualization is done and what are the marketplaces in the virtualization. And I can explain you the Vagrant, which is type 2 virtualization, which you can set up your own lab in your own laptop so that you can practice whatever we learn in the class, like cloud basics, how cloud works and why cloud evolved. Then we'll go into the AWS. In this AWS, I'll be going to give the clear picture on compute and how the compute has to be chosen. Next, I will be explaining the storage, then networking, then logging. Then first, we'll be seeing the identity access management, which we give access to the people. In the same way, we'll be walking through the Google Cloud Platform basics. Then I will be explaining the Python. Python will be like very basic, like so you need to understand the coding. So I need to explain on the Python basics. Then we'll see the version control systems Git. And next, we'll go into the continuous integration and continuous development, which we used to do with tool called Jenkins. Then there are many configuration management tools like Chef, Puppet and Ansible. We'll be learning the Ansible in our session. The competitor for the virtualization, the Dockers. The Dockers will be learning deeply. Then we'll learn the Kubernetes basics. Kubernetes is on top of Dockers, where we'll automate the Dockers like into the container world. Container orchestration tool is a Kubernetes. So I'll be explaining the Kubernetes. Then we'll see the infrastructure as code, that is Terraform, where we'll be launching all our instances using the Terraform. We don't need to go manually into the AWS cloud sign in and then we need to launch the instances. These all mechanisms will be automated. So this is our whole architecture, whole curriculum of this DevOps course. The demo sessions are completed. We'll start from the basics like virtualization and everything. So you don't need to worry about the job market. It is like huge opportunities are there in DevOps. Almost 65% of organizations are moving towards the DevOps lifestyle. Everyone has to do everything and there is no hardcore developer and hardcore quality analyst, hardcore QA guys. It is like everyone has to be in this IT world. Means we need to adapt to all the tools. So if you see the trends, you can see, you can go into this link and you can see the trends of how the DevOps market is evolving. So for today's session, we'll see what is container orchestration, what is container orchestration, Kubernetes introduction, what are the principles of operation which drives Kubernetes, and we'll work with the pods and what are the deployments. So to understand container orchestration, first we need to understand what is a virtual machine. So virtualization, it has two types of virtualization. Is nothing but so you have a computer, CPU, memory, networking. So these are all present in your system. You take your personal PC or you take any server. These are the basics. These are the basic infrastructure you have in your systems. If you take the servers, it will have larger memory, like larger CPU. Same thing will be available for the servers as well. Whatever is here will be available here also. In virtualization, you have to use maximum of the capacity of these things. You need to use we'll say like optimum utilization of resources, right? In the same way, we need to use this in a good manner. Previously in olden days, what we used to do, one server means one server is dedicated for one application. If you have a web application, your total server is dedicated for the web application, which is like very bad. Suppose you have a CPU of 16 CPUs, 32 GB of RAM, and you have maximum supporting console ports. You might say like 10 console ports. It supports the network. So These are all dedicated to one web application. Example, in the olden days, like before virtualization evolved, all will be having web application totally will be using this server. So which is pretty odd, like we are losing our resources. We need to be optimum utilization. That's where the hypervisor, that's why this virtualization evolved. Virtualization concept is you have a system and you have the resources here. So here you have a resource. These are the resources of the system. Whatever I spoke up to now, like CPU, memory, networking, all these resources are there under at the end. Now we need to use these resources pretty well. So in virtualization, what they have done, they have introduced a new technology called hypervisor. This hypervisor is nothing but a piece of operating system, you can say, which makes your resources to utilize properly. This works as an OS and you can better utilize your resources, like it will be a separate system. Here you can use Linux. This might be Red Hat Linux. This might be Windows. This might be Ubuntu, and this might be Android. So you see there are 4 systems and you can dictate all the resources, like how many CPUs it needs, how much memory you need to have for each and every system. Here you can decide, you can use 1 CPU for this, 2 CPU for this, 4 CPU for this. Based on your application criticality, you can decide and you can install your application one of the system. Here we say 2 terms, like there will be 2 terms. One is host OS, guest OS. So host OS is nothing but the hypervisor which you are using, and in virtualization, there are 2 different types of virtualization. They say like type 1 virtualization and type 2 virtualization. So in type 1 virtualization, you will be configuring the big servers, like whatever I spoke up to now. Type 1 means like you might see the IBM servers, Dell servers, HP servers, and there are bigger servers which we maintain in the data center. So this kind of virtualization is nothing but the type 1. It is a bare metal virtualization. And if you see type 2, it is automating, it is virtualizing your PC. So how this works, how we need to do these things, like I cannot demo the bare metal because you need to have a server where you might be hearing the VMware, there are Rackspace, and there is a Zen server. These are used for making the bare metal virtualization. If you see the VMware has many things which you can make your bare metal, but to configure as much as, like based on the capacity, you can increase your virtual servers. Like in the modern world, when before the cloud has evolved, this virtualization has played very prominent role in the organizations. Like if you have 100 members of the staff, if you are developing an application, so each and every guy used to have one VM specifically assigned to them, so that they can do their work and they can commit their code in the centralized repository server of the organization. This has given an opportunity for proper utilization of our resources, not to waste any CPU, not to waste any memory, and not to waste any such type of networking which is available in the infrastructure. This is the type 1. And type 2, you might be seeing in the market like Oracle virtualization. If you see this, you can make your system a virtual server. If you install this one, you can make your some of the instances. If you're having a Windows OS, on top of that you can install your Linux, whatever the Linux you need. If you see, it supports Solaris, Windows 8, Windows 7, and Linux 2.4. If you see here, it supports lot of versions. So we can make our system a virtualized server. Practice, like some of the applications before giving the demo, people used to run on these virtual boxes. So for the demo sake, they will have a demo software which they can install and they can show the customers and users how it works. So we can automate. How we can automate? That is the way we used to do with Vagrant, that we will see in the coming class. If you understand the virtualization, next the competitor of virtualization is Docker. How this Docker works is like, you don't need to make an whole server like we saw, right? In virtualization, we used to see like we have automated, we have better utilization of resources, and we are having different OS on the different virtual machines. So these things are making the server more like utilization of, on top of one OS, you are installing one more OS, which is making heavy processes. You are handling very heavy process. OS is nothing but a process. If you see a total OS is running on top of another OS means it is actually eating your resources. So in competition to the virtualization world, one more concept came, which is like containers. If you see the containers, how it works, just as I explained, there is a physical server. On top of that, there will be a hypervisor, and this is a guest OS. Whatever OS you might be installing, it will be having the bins and libraries to execute some specific application. So coming to the containers world, this containers world is like you have a physical server or a VM. On top of that, you will be having your operating system, say Linux. On top of that, you will be installing a Docker engine. This Docker is a container engine. Like there are some players in containers. Like Container D is one of the player, Docker is one of the player, and Rackspace is one of the player. In these three competitions, I think Docker has taken 80% of the organizations, 80% of the world. They are ruling now. How the Docker works means you don't need to install a guest OS on top of that. You need to install a specific Docker engine, and that container engine will build some images. Like suppose you have a web application. So if you are developing using a Python, in Python you might be using Django, or you might be using the Flash. So what you do, your operating system will be having some bins and library, and you use the same thing and use a piece of software which whatever the Django application or Flash application, you will be building with that, and you use underlying bins and utilization, and you build an image. Like how our operating system evolves, in the same way you can build your own image which doesn't need a guest OS in between, and you can directly install that image on top of the system, and you can run. In this way, you can see the physical server or a VM is utilized properly. You don't need more resources, and you need only minimum resources which you need for specific application. And if it is not my web application, and if it is my telecom application where I have prepared a stack which will answer all the telecom calls. So for stack, I don't need to have a web application installed in my system, and I don't need to have a application server installed in my system. I need only the stack which is supporting the call. If I make a mobile call, I need to answer from the other party. That is my main goal, and I need to support some 25,000 calls. Means I can build only that much application, and I can install that in a VM or a PC which supports, which takes only the resources which it needed for the application. So this way, the virtualizations are beaten by containers, and in this current world, this is the booming technology. Like everyone will be moving, most of them by 2025. I think how the VMware market has taken over in 2010, same way the containers will be taking over the IT in coming years. Almost now itself, almost 50% of people are using the Dockers and Docker containers in their organizations and building their own images. And if you see, it has a very big community which supports and which has already available images, and you can just take it and customize it for your application. So these are the containers, like how we build the container. So you have the container. So what we do, we actually prepare the infrastructure. How we prepare the infrastructure and how we automate, how we orchestrate these containers is nothing but Kubernetes. We use the tool called Kubernetes, and there are different tools to orchestrate. First, we need to know what is an orchestration. So in the current world, if you take the word called orchestration, if you see on the left side, you will be seeing lot of musical instruments, right? What is this means? Like if an orchestra is there, if you want to get a good music, soulful music, if you want to listen, you need to mix and match with each and every tool to generate a proper music, which can be a soulful music, which can be a melody, which can be a beats music. You need all these tools which makes you better, which makes you use in a proper way to set up your server. In the same way, if you come to the IT world, and if you are using containers in your organization, so how you can create your own infrastructure using the Kubernetes is like you have different firewall setups, you have different web servers, you have different middleware servers. If you want to create your own setup, if you want to create a setup using the containers, you need to orchestrate those things. And the container orchestration tool is Kubernetes. So orchestration is nothing but deploying your application, making your own data center with different servers, whatever you need. So how this going to happen, and why we need to go for Kubernetes, and why we need to exclusively choose the Kubernetes as our tool to make our data centric OS using the containers. Means there are lot of competitors like with this container orchestration. If you see, there is a Docker Swarm, Mesosphere, Kubernetes. So what is the difference? Why we need to choose the Kubernetes means like you have a Docker Swarm which will automate only the Docker related container. And if you are using the container D orchestration, this container D is one another tool which you can make your container. So if you are using container D, you cannot use Docker Swarm. And Mesosphere is very like it is developed by Apache, and if you want to do coding with Mesosphere, it is very difficult. And if you come to the K8, normally Kubernetes they call it as K8. If you see the symbol, this is like a ship, and if you see the Docker symbol, these are like bins and libraries. And Docker is nothing but it is a shipment, and you are using a ship with your all required software, and you are doing this. And if you want to ride this ship, and if you want to go in a proper way, you need a master who drives that ship. So if you see the Kubernetes symbol, right? If you see the Kubernetes symbol, you will see it shows that. You see this is the Kubernetes symbol. Like it drives the ship. So it makes a proper utilization and proper way how you can install your data centric OS. That's where like if you take container D or Docker or Rackspace or anything, you can use Kubernetes for orchestrating all type of containers. Whatever there in the market, it can orchestrate everything. It can do orchestration and each and every player who are developing their containers. So why Kubernetes is chosen is one more reason is like it has a DNA of Google. So it has a very large community, and if you want to majorly like face any problem, there is very big community which solves your problem very easily. So that's why Kubernetes is preferable to orchestrate the container. So now the cloud native computing foundation has taken over. We'll be adding the different versions for Kubernetes. If you want to see how the Kubernetes cluster looks like, this is the low level architecture. How the nodes are installed. There will be a master server and there will be worker node. You might be known about the server and client architecture. It is the same way. There is a server which runs APIs to deploy your application, and on the worker node, actual work is done. Whatever the application, if you are having a web application, if a web application is like hotel website, like flight booking website, if you want to deploy, you can deploy in the worker node. And why the Kubernetes is preferable means it is auto healing. It is like support the auto scaling, auto healing. All these features are embedded in the Kubernetes. You don't need to go manually and do like your server has crashed and you need to create one more server. It's not in that way. Like once if you write your program in Kubernetes, once you set up your servers, and if you want to run some 4-5 servers at the same time, and if any server got broken in between, you don't need to go manually and do the server up again. Kubernetes takes care of that. That's why it is very good tool for orchestrating the container application. We come to the major architecture, how the Kubernetes looks like. So as I told, it's a master slave, how the master works and how the node works. You need to understand that. So if you see the control plane, you might be seeing an API server, you might be seeing the controller, you might be seeing the database, you might be seeing the cluster store and scheduler. And what are these? You need to understand properly so that you'll get an idea how you can deploy your application. Suppose if a user has written his code of a container code and he injects into the Kubernetes server. First, master comes into place and it takes the request from the API server. And this API server validates it and it sends to the controller. So the controller sees the actual state and the desired state. It should be equal always. Whatever you desire, you need to have that and you need to launch. And it stores the cluster information. And scheduler, it revamps like how many nodes you want, like how many copies you want to replicate it. And scheduler takes all these things. And scheduler runs the job. If you have any infrastructure and you want to test daily that system supports all the features, and you have a job which should run when all the users are on rest. Like midnight 12 o'clock you want to run, you can create your cron job, which scheduler takes care and which runs it. So if you see here, I have written make all scheduling decisions. Control plane makes all scheduling decisions. Monitors the cluster, how many nodes are down, it always monitors the cluster, and whatever the user implemented changes, always makes the changes, and if it goes back to the older version without hesitating and respond to all the events. So this is like how the control plane looks, and we'll go deeper into that. This is just a basic knowledge you need to have. And what is node and how is this node? See, as I told, Docker is nothing but container images, and what
whatever the images you are having, and those images which are pushed by the API server will be pulled from this container runtime and it will be run in the node. And this kubelet is a process which always informs the master that it is alive and it does the operation. And there is one more attribute called kubeproxy which maintains network between the nodes. So if you have some 4 nodes, if you want to have a communication channel between the 4 nodes and the master, your kubeproxy should always be running in the backend so that it always maintain the communication between the nodes. Control plane is nothing but it controls all the servers in the cluster, and the data plane is nothing but where your software actually runs the application services, reports the master continuously that it is alive, or if the application is running and if it is giving some output which has to go to the end user, it first reports the master, so master will take care and it will show the output to the end user, and constantly watch for the new work assignments. Like whenever the controller gives new work, it automatically does using the kubelet. As said, the cluster is the brain of it, is the master. Always the control plane is the brain of any software. Like you take any master and server object, master is the brain. All the controls and scheduling decisions are made in the production environment or multi-HA, like high availability deployment. It's the master's job. So what exactly the API server does is like, it's a front-end service which interacts with the user directly and it uses the RESTful APIs. And your request may come in JSON or YAML file. YAML is one more scripting, like at another markup language. It is very easy. Like if you are aware of any scripting job world or in your education time, YAML is very easy. Like you don't need to struggle for YAML, and which we use and which we have to be aware before writing the Kubernetes scripts. We write all the Kubernetes scripts in YAML. And what the cluster store is nothing but it makes the state, it uses the state of the node and it keeps that state in the database. The database is nothing but etcd. It's CD they call. It's a distributed database. All information about all the nodes which it is getting communicated from different nodes to the master, that state everything will be stored in database. If you see the control manager, this control manager, I said the events which are coming from the node and the controls and the watch loops. Watch loops is nothing but the jobs, and if you want to run the job for 10 times, it will run the job. If you have any cron job, it will run the cron job. So control manager you will take care all the configurations you made and it will run according to the time. If you see, each loop watches the changes at API server and aims to ensure the current state of the cluster matches to the desired state. See, in this world, if we build a software, always we expect, like if you have an Android phone and if you install an app, when you click on the app, you always see like it works fast and it satisfies your needs and you can do your operations using that app. In the same way, the current state, like if you desire to have your state serving some request to some user, the current state and desired state always it should be equal. Means you should be serving. Otherwise, it is not. And you will go into a panic state, like your resource if it is gone bad. So your current state it cannot be equal to the desired state because it's already lost its communication with the master. To maintain the current and desired state, the control manager always works with the worker node. This scheduler is the scheduler watches for new work and assignments, assigns it to the nodes, and it always assigns the work to the node. And affinity and anti-affinity rule. To explain this, I can say like affinity means like a small example, like you have a good night vision in your home for the mosquitoes. So what you do, you keep a chemical in the good night so that chemical will be spread across your home and it reduces the mosquitoes, right? And if it gets used to that, you will change the chemical. Like if mosquitoes get used to that, you will change the chemical where the mosquitoes will go away. In the same way, you will create affinity rules and anti-affinity. Like if you have affinity means like whatever rules defined by you, like I want a web application. I have a web application server in one node and I have telecom application in another node. So I write a script which allows even if API server, it triggers a work node which has a web server, it should not come into the telecom application server node and it should not install in the telecom application server node. It should always install in the web application node. If it is going into telecom application server, that means we have not defined the affinity rules properly. This is a small example and we'll see practical things of all these things in the coming sessions. Next is cloud control manager. If you are using any cloud, normally in this current world, everything is API. Your cloud providers will provide an API which will talk with your Kubernetes API, and it maintains the load balances and manages the node. Coming to the data plane, this registers the host as the worker node. As I told, this is the process which runs in the worker node, and whatever the worker node it is running, this kubelet is the communication channel which talks to the master server and maintains the state, and it assigns a task to run and to create some applications in the worker node. And the container runtime, if you see the container runtime, it pulls the images. As I told, like VMs will have an OS and a specific software which works in the same way. You will create your software using the images. In containers world, images are called software, and this container runtime will pull all the images which and all you have mentioned in your script, and it runs. Unlike container world, you can run multiple applications in one shot. So next is Q proxy. This is a local networking which maintains unique IP addresses for the worker nodes to communicate with the master node. So just we can see one practical. This is a Docker hub. This is a community for the Docker. If you search, suppose I want a MySQL server which has to be installed on my worker node. If you go and see, someone might have already written. This is the Docker hub is nothing but the repository. So they have an official image. Just you can pull that image, and if you click on that, he might have given the steps. So just you need to pull that, and you can see lot of things, like you have Node.js, you have specific Java applications, specific Oracle servers which are already built and which are there in the repository. So if you create your own account, right, you can pull lot of images which and all you need. Even for OS, right, you have specific images. For Ubuntu, you have specific images. For Red Hat, you have specific images which you can directly pull and use it. And these are the commands which you use to pull. But in Kubernetes, we will do everything through our script.
This container is nothing but like a predefined set of software images will be available, and we need to pull them into Docker.
Yes.
And
yes.
how about if we want to install any other software other than which are not there in image or the container, how can we install? I mean, how to do it?
Okay. For that, we need to write our own Docker image. Suppose for my application, I need Java in the backend. I need a DB as a MySQL, and I want to install my piece of software which I need to deploy into that. So for that, what we need to build our own image saying, I need Java. I will download the Java image in the same file. I will download the MySQL image in my own site. I will copy my piece of software which runs on top of that. That's where the shipping I have shown, right? There are a lot of packages in the ship, containers in the ship. So you can use multiple containers into the same image, and you can create your own image, and you can build your own image so that you can use your own image into your software, your own image into your container, so that you can, if you run that container, it satisfies your problem. And how you create that is like this Docker file. If you see here, he has an Ubuntu file and he has his own app. He is copying from his machine, and he made an app, and this app is a Python related. So when you run this one, it runs his actual server. So in the same way, you can create your own images. Like on top of this OS, you can create, copy a Java software from Java. Some version will be image will be there, and you can put that image here only.
This is what kind of scripting, which language?
This is not a scripting. This is a Docker template, like Docker first, how we build the Docker. We will go through this one. I can explain this in the Docker feature. Just today for the demo sake, I just taken one topic. Otherwise, we come across the code so that by step, if we come, we'll be able to understand. After I explain the Dockers only, I will go to the container, Kubernetes.
Sure. And so one more thing, explain about control manager and the scheduler, right?
Yes.
So you said that scheduler will take care of each service. For example, if you have two web servers, if the user is requesting for one web server, should go to that particular, it controls. And what is the difference between control manager and controller manager also will do same thing, right? Controlling the user requests and responses.
This I can explain more clearly. So controller, as I told, if you design your worker node, this is the worker node 1. So here you are installing web application server, and here you are installing telecom application server. Your API server got a request, and it has a file which says, like, it has a code, like it receives a JSON file or a YAML file which has a code of telecom application server and web application server. So when it is submitted to the API server, it is submitted to the API server. It stores the configuration. So controller, it sees the rules I designed. Here I said this has affinity called W, and these are blue applications, like I say color. These are green applications. So when the request comes, right, it sees whether this is green or blue. Whatever the code it is coming, right, whatever the application you are setting up, it sees the affinity and it launches into specific worker node.
Okay.
This is the job of control manager. And if you say the scheduler, right, these are all nodes are already there with the required software. And what I need to do, I have one more patch which I have designed. I've given to the application server. So I want to run this. I want to run this on specific like telecom application server, and I want to do the load test, and which I want to do at the night only when the users are not using. I want to do that time. So I will schedule a job and it has to run up to 25,000 times, so that if I make 25,000 calls also, it should not crash. This will be taken care by the scheduler, where the control manager will give only the code, but how to run, how many times it has to run, that everything will be taken care by the scheduler. You got clear, right?
Yeah, they communicate each other, I guess.
Yes, it is like master plan means like every component will be having communication between them. And if you want to do the practicals for the Kubernetes, you don't need to have your software installed on your machine. There are a lot of online tools. Even we can install on our machine, and if you don't want also, we have like Kata Cloud. This is an interactive platform to experiment whatever you have created. So it comes with automatic master and slave. As I told, I have created my own server using Vagrant, which I can share with you guys to run, so that it creates like if you want to create a standalone application, right, there is one utility called Minikube. You can see the documentation, Minikube install. So this Minikube is nothing but you can set up your own virtual server, virtual machine with the Kubernetes cluster, and everything will be installed in your system. Whatever the master and slaves, everything will be installed. This is my Vagrant file. So if I run that, so in the meanwhile I can explain what is a Vagrant. This is a piece of software where it will make you to create your own machines, like own virtual machines, without having a VMware software or something else in your server. So this will create, and this will give a good glimpse what OS you need and how much CPU you need. Everything you can configure. I can show the just a sample Vagrant file. So if you see, I've configured with my own network IP, and I'm using the Ubuntu as an image, which will be downloaded from the Vagrant website itself. And I have not specified how many CPUs I need. I've just used the whatever the system specific, like default thing. So I've created my own file with the web servers and DB servers, and it will be attached with this IP. So if I want to log into this one, just I need to give Vagrant SSH, and this is my VM name. So the default user which is created to log in is Vagrant. This Vagrant will have one whole specific class on Vagrant itself, so that first we'll set up our own machines in our laptops, so that when I explain also you guys can directly do with me, so that you will have a good idea on what and all operations we are doing and why we are doing. So this way you can create your own servers. See, it has logged in, and if this is Ubuntu, so I can do Ubuntu uses app package. So I need to be a sudo user. So it updates, like you can create your own vision, and I think it already had the Kubernetes installed. So it has already installed. These all things I will be giving demo in Google Cloud. Currently, I have not set up any Google Cloud cluster, so I am showing on my PC. If it is on Google Cloud, it will be a lot more faster. So in the meanwhile, may I know on what applications you guys are working? Just if you want to see how it is set up. So it has a master and a node, and if I want to just install in the Kubernetes world, to install the Docker multiple images into one, we term it as a pod. A pod is a unit of a Kubernetes platform, like unit resource kind of thing. If I want to do that, I'm creating one NGINX server with the image, and if I don't give anything, it takes default as the latest. If I want to see the code, this is the command line where we generate the code. As I told, it has an image. This is a Docker image, NGINX, and the container information you are giving, and you are using the image NGINX, and you are giving the name as NGINX, and this is the base, like what and all we need. We can add more, but this is the basic thing. And if you want to create it, you can just create. So it has created, right? So if you want to see it, so it has an error in the full image. If you want to see the logs, you can describe it. Same command you can just use to describe. This is all the information which is generated from that. So what are the labels, annotations, IP address for that. So affinity created with the tolerations. The name used to see in the in the log is toleration, so that it defines your affinity rules over there. And what went wrong? Why it has not pulled the image means, you can see I have given the name as wrong. NGINIX I have given. So which there is no image available, so it has not done that. So if I change this, I will delete this because it's already created. It needs to be deleted. Then we need to create again. You see, now it is creating. You want to see continuously. Now it's running. So your container is ready so that you can deploy your application on top of that. This is how we deploy multiple servers. This is a small demo. It will go according to the plan, whatever the course and curriculum we have, go according to that. And the last topic is Kubernetes actually. For the demo sake, just I took this one, which will give some understanding why the containers are getting most importance in this world. Just for glimpses sake, I have explained the Kubernetes. So once the regular class starts, you can go according to the plan. Whatever I have put in the curriculum will go according to that. Thank you.